Question 5. This question is about ionic compounds and electrolysis. Calcium chloride is an ionic compound. 5.1. Calcium and chlorine react to produce calcium chloride. Describe what happened to calcium atoms and chlorine atoms when ionic compound calcium chloride is formed. So the first point is calcium will be losing 2 electrons. It's in group 2. It's a metal, so it loses 2 electrons. This is how we write it. Each calcium atom loses 2 electrons. Chlorine is in group 7. It needs 1 more electron to be 8, so it's gaining an electron from calcium to become chloride ion. But we have 2 electrons from calcium, so we need 2 chlorines. Each chlorine atom gains 1 electron. So we can write it this way. Cl2 plus the 2 electrons, because it's 2 of them, each one of them is gaining an electron to become 2Cl minus. 1 calcium atom reacts with 2 chlorine atoms. You get 4 marks. Each color is referenced by the 4 marks. 1, 2, 3, 4. Question 5.2. Calcium chloride cannot be electrolyzed. Give one reason. Well, because it's solid, the ions are fixed in solid, hence they cannot move. Question 5.3. Name the product formed at the negative electrode when aqueous calcium chloride solution is electrolyzed. So this is the reactivity series of metal. Now if you look at here, what will be discharged? Well, calcium is higher in the reactivity series. A less reactive one will be discharged. So ions of less reactivity discharged. Yeah, so hydrogen is less than calcium. So hydrogen gas, H2, will be discharged. At the anode, you get 2 chlorine, yes, and then forming the chlorine plus 2 electrons, because chlorines are releasing the electrons here at the anode, and the electron goes to the cathode, where at the cathode the H plus will gain the electrons and then form H2 gas. So that's how the process happens. Question 5.4. What is the half equation for the reactions at the positive electrode when aqueous calcium chloride solution is electrolyzed? Well, so you saw that earlier. It's this one here. This is the one because we showed it here. As you can see, that's what would happen at the anode. The positive electrode is the anode, and so this is what would happen at the anode. Question 5.5. A student investigate the electrolysis of green copper chromate solution. And figure 4 shows the apparatus. You got power supply connected to a negative electrode, and that power supply is connected to positive electrode plates. And here you've got a drop of green copper chromate solution, and the paper is a filter paper soaked in an electrolyte solution. Figure 5 shows the result. So you got the power supply again. You can see there was a blue color here and a yellow color on that side. Copper chromate solution contains the ions of copper 2 plus and chromate 2 minus. Explain the result shown in figure 5. So we got copper 2 plus, which is copper ion, are blue, and chromate 2 minus ions are yellow, because that's what this is showing you. The blue here is copper 2 plus, and the yellow here is the chromate ions, and they are yellow. Copper 2 plus move to the cathode, the negative side of the electrode, because it was there, so it migrates towards there, negative side of the electrode. And chromate 2 minus move to the anode, positive side of the electrode. That it was there before. If you look at here, it was there in the center, and then that chromate, because it's negative, it moves to the positive here, and that's what this is saying.